Let's go. So the National Trust own 25,000 hectares of peatland, and of that 25,000 hectares, 17,500 hectares are degraded in some way. So our aim is to have 13,000 hectares of our most degraded peatlands under restoration by 2030, and the remaining 4,500 hectares under restoration by 2040. So this is going to contribute towards our net zero ambition by 2030, and also deliver against our targets of improving the condition of our A and SSSIs, and existing priority habitats, and also our targets for restoring and creating new priority habitat. So, sorry, I didn't introduce myself. I think let me just take a step back. So, my name's Tia Crouch, for those of you that don't know me. I am the National Trust Peat ecologist, and I've got a central role, so I cover England, Wales and Northern Ireland. And I've been working on trying to come up with a standardised way of monitoring for our peatlands. So we need to collect data to understand the current condition of our peatlands, what work we need to do to restore our peatlands, and how the condition changes because of peatland restoration interventions. And we need all of these data to be collected in a consistent way across all of our peatland sites. And that's going to enable us to bring data together to evidence the impact and also our progress against our targets. And we need to be able to do that at lots of different levels. So internally, we need to be able to do that at the site and property level, the country and region level, and also that's a big whole trust level to kind of know what condition our peatlands are in and how we're changing that over time. But also externally, so the trust is a big landowner, so we've got quite a big role to play in delivering the government's peatland restoration targets as well, and also the net zero ambitions. So the National Trust peatland programme is relatively new. So over the winter of 21-22, we ran a series of work streams, and these were set up to discuss all different aspects of peatland restoration, one of them being data and monitoring. So the data and monitoring group agreed that the metrics that we needed to have data on to help understand our peatland condition were the extent of peat, peat depth, vegetation and peatland condition. We needed to know where all the different peatland features were, so where we've got bare peat, grips, gullies, hags, and also what the water table was doing. So we already have some of these data across some of our properties with peat, but it varies in the degree of coverage. And that depends really on how long those places have been doing peatland restoration, what resources they've had to deliver that work. Until recently, there wasn't really a standard way of collecting those data. So a lot of properties will work with the Peat Partnership, so they might adopt the Peat Partnership methodologies. They might be working with universities, so the methods might be determined by the universities that they're working with, or they might just come up with methods that work best for those places. And often, the screen's doing something funny, so often the other thing that's really important for me is that that data is held centrally. So most of the time, data that individual properties collect will sit at that property and I can't then see it. So it makes answering those big questions impossible really if I don't have access to those data. So one of the pictures. So the aim of the peatland monitoring approach was to agree methods and data standards for collecting data on our peatlands to support our teams on the ground, and also allow us to process and manage data efficiently. I didn't want to reinvent the wheel or make data that had already been collected redundant. And I think that was a concern of places that have been doing peatland restoration for a long time and have lots of data. But what I did want to do is create a bit more structure for future monitoring. So I looked to what data was already being collected and to existing national schemes and data standards, existing data standards that we could adopt to provide the data that we needed. So I was going to show you a nice table at this point, which shows the metrics that the data workstream identified and how those fit into the sort of existing national schemes that we're adopting. But I'll explain that as we go on. So the peatland monitoring approach focuses on the impact of interventions on peatland condition, but also encompasses pre-survey, so that sort of mapping work to map where your erosion features are, and also your baseline survey. And it provides a tiered and layered approach to peatland monitoring, so as I say, using existing national monitoring schemes to provide a basic level of data across all of our peatland sites. And importantly, for places that already have lots of data, detailed monitoring, it doesn't prevent them from doing more detailed monitoring or innovative or experimental research. So the monitoring approach is sort of split into 4 levels, and the ambition is that the level 1 monitoring would be carried out at all of our peatland sites, and it's based on Eyes on the Bog. So I'm sure many of you are aware of Eyes on the Bog and what it involves, but for those of you who don't know, Eyes on the Bog provides robust, reliable, low-tech, low-budget and long-term monitoring, and it uses surface-level markers to measure peat subsidence and peat accumulation. So those of you that went on the Great Fen visit yesterday, it's kind of akin to the home fen post, and I think that's probably where the idea came from. So it also uses rust rods to look at the general behaviour of the water table, von Post tests to look at soil condition, and fixed point photography to look at vegetation, structure and composition. And we've also added in an optional quadrat so that people can record a little bit more detailed vegetation information. So still quite high level, so using species groups, and an option of whether to record presence, absence or percent cover. So trying to tailor it a little bit to people's abilities and what they feel confident to do, because monitoring at the Trust, it might be carried out by volunteers, it might be carried out by rangers. Yeah, unlikely that Eyes on the Bog would be by consultants, but some of the more detailed monitoring might be carried out by consultants as well. So there's a range of people that will be carrying out monitoring, so it's trying to cater for lots of different abilities, really. So our level 2 monitoring, which is our recommended minimum level of monitoring, and the ambition with that is that it will be carried out wherever there's a new peatland restoration project planned. And level 2, so all of these levels build on the previous one. So we would expect people that were doing level 2 monitoring to also do Eyes on the Bog, and just sort of build the detail of the monitoring up, really. And level 2 is based on the Peatland Code field methodology, so to collect more detailed information about the site. So Peatland Code field protocol, it involves desk-based mapping of your erosion features and drainage features, and also a survey of peat depth and peatland condition that's carried out on a 100 by 100 metre grid. And then moving on to level 3. So level 3 for us applies wherever there's country or project-specific monitoring. So for example, Nature for Climate, Peatland Grant Scheme, or in Wales, the National Peatland Action Programme have monitoring that people would need to do. So we need to build that into our approach as well. So again, level 3 still builds on the previous level, so we would still hope that people would have eyes on the bog monitoring and that they've used the methodology, the Peatland Code field methodology as well across their sites. And yeah, so that's ensuring that we've got that basic, consistent data across all of our sites so we can compare between all of our sites. So monitoring at level 3 is really about how the restoration activities have impacted the sites. So the type of monitoring that's carried out at that level is going to be related to the type of intervention that's happening on that site. So places might be looking at the impact of restoration on vegetation, using vegetation quadrats, or they might be looking at the impact on water tables, using dip wells. Level 4 is for sites where detailed and innovative or experimental research is being carried out. And again, builds on the previous levels that have come before. And again, level 4 is going to be very specific to the research aims and objectives, which could be anything really, but some examples being the impact of peatland restoration on runoff and channel flow, impact of peatland restoration on the carbon balance, impact of flailing perhaps on flailing of millennia on sphagnum plug success. So yeah, that could really be anything. So the other things that I've been thinking about in all of this work is how we collect, manage, store and view our data. So we're creating apps for our teams to use in the field to ensure consistent data collection and access to the data by both at that property level and at that whole trust level. Data from the app uploads to ArcGIS online, and it can be viewed there. It can also be opened in ArcGIS Pro to be edited and if places need to work with their data. Not everyone within the trust uses ArcGIS Pro, so we're also developing web apps as a sort of intermediate way that people can view, edit, work with their data, and that's still a little bit of a work in progress at the moment. So where possible, we'd like to adopt agreed data standards for our peat surveys. However, as far as I know, there aren't any agreed data standards for peat surveys. I know Natural England have developed a standard for peat depth data, which is detailed in their data exchange document, and that's been used for people, kind of guidance for people submitting data to the England peat map. And future versions of that, I think there's an intention to kind of cover other peat surveys as well. So things like your surface features, vegetation mapping, peat condition. So once all of the app development is complete, the next task really is to develop an analytics type dashboard so that we can analyse data, answer questions and track progress against targets at all of those levels again, so your property, region, country, whole trust level. And I'm also really interested in developing peat data standards for the key peat metrics. So if there are people in the room that are interested in maybe moving that kind of work forward, then please come and have a chat to me afterwards. And that's everything. Thank you. haven't spoken to him, but I have read the paper that he worked on that was starting to identify the metrics. But yeah, I haven't followed that up with actually speaking to him. Yeah. Yeah, I think, yeah, definitely. And there's no reason why we shouldn't be able to share it. And actually, I'll say this here as well for people that aren't in the trajectories workshop later on, which was just going to be an offer really that, particularly in terms of trajectories, but I think it applies to data as well, that we're probably not the right people to be leading on any of this work, but we're very keen to link up sites, practitioners, academics, and kind of help with those collaborations and help facilitate things. So yeah, we can definitely provide sites for research and we can share data. There's going to be, there might be some data that I guess where we're already working with academics that can't be shared immediately, but this kind of data that I'm talking about, there's absolutely no reason why that can't be open and shared.
Hi there, Maura Gangas from the Southwest Peatland Partnership. You mentioned that you've got tier 3 around or stage 3 around monitoring, around project-led monitoring, and I just wondered why you've chosen to include that, because I say personally, like monitoring under the NCPGS grant or anything like that is very short term, so it's like 4 years, you do specific monitoring for that project, and then that project finishes, what happens to that data? You can't continue it because you don't have the funding to do that. So I just wondered why you sort of chosen to keep that in and not have a more sort of strategic sort of monitoring across your sites.
I think it's just acknowledging that for certain projects, places are going to have to follow a certain method, and if I didn't include that or a certain approach or whatever's required of that project, if I didn't include that, then there would be questions about that. And while it's maybe only funded for a few years, those methods are fairly transferable, I suppose. So if you're doing quadrat monitoring or you're monitoring dip wells, particularly within the trust where we're able to work with quite a wide range of volunteers, once those monitoring sites are established, there actually isn't any reason why we shouldn't be able to. I mean, they might not be monitored every year, but they could stay in place and still be monitored maybe on a 3-year basis or something like that. Does that answer your question?
Yeah, thank you. I've just got another quick question. So you're sort of mainly talking about sort of ecological, hydrological monitoring, and I just wondered what your sort of ambitions were around historic environments for doing monitoring of that.
Around what environment, sorry?
The historic environment.
Historic environment. Yeah, so that doesn't actually feature in this approach. So I think that there's such a lot that you could talk about. So this is really focused on, it has focused on ecological and hydrological monitoring, and it obviously factors into when we're planning interventions, but it hasn't been part of this piece of work.
Thank you.
Yeah, hi. I'm Peat, University of Exeter. It sounds like exciting, lots of data coming in. Are there a lot of plans for analysis and where and how you're going to use it all? Particularly stuff, like the photography work or dip well stuff. Do you know how it's being planned to be used?
So, I guess at the moment, probably the most important level of monitoring is going to be that level 2. And because the questions that were being asked at a whole trust level by the sort of more senior directors are, what condition are our peatlands in? And we can't answer that question at the moment. So to be able to know the extent of our peatlands and actually using the framework within the Peatland Code, be able to identify what area you've got in each of those condition categories, that is going to be super helpful in terms of talking to the senior directors and giving them the information that they want. I think that more detailed monitoring is probably more relevant at the property level, where they're, you know, smaller scale monitoring and trying to see the impact of the interventions that are occurring at individual sites. But yeah, it's definitely a work in progress, and there does need to be more work on thinking about how all the data gets analysed. But I think initially it's that sort of high level data that can be brought together in quite a simple dashboard that would be used for high level reporting. That's where I'm at with it at the moment, but yeah, more work really to go on that.
Did you have a question?
Yeah, two questions here. So first one, you talk about 4 levels and say you've got 17,000 hectares of degraded peat. What proportion of those levels do you see assigned to spatial areas? And then the second question is, you haven't really mentioned any kind of remote sensing data in that monitoring approach, and you kind of maybe all 4 of those levels, and that's kind of going to be a big thing, especially if you've got 25,000 hectares of peat. Do you think that's going to... is that built into your monitoring eventually?
Yeah, so this guidance is really designed for people working at properties to help guide their thinking on how they approach monitoring. In terms of where, how much area would implement each type of monitoring. So we'd like to see that level 1, eyes on the bog, on all of our peatland sites. Obviously, it can be set up in different ways. It's pretty flexible in how people use eyes on the bog. But yeah, the hope would be that every property that's working on peat would have some of those monitoring sites set up. The level 2, as I said, is when properties are undertaking a peatland restoration project, then they would use that method. So that's going to increase over time. It would be too much to ask. Like, a lot of the National Trust teams are very small. They don't necessarily have people that work specifically on monitoring. It might be rangers, or it might be... So if I use Marsden as an example, then they've got a team of brilliant volunteers that go out every week and do monitoring work. But it really varies by property. Again, if there's projects coming in, then there's likely to be funding that's going to facilitate some of that monitoring. So I think, yeah, that's going to vary. We're not expecting everywhere to do that method over their entire site, because that just wouldn't be practical. So it'll be building up the picture over time, and I think that's probably the most realistic way of approaching it. In terms of remote sensing, yeah, we have thought about that. So at the moment, I'm working with our remote sensing specialist, because again, what would be really, really useful, but I won't talk about this too much because it's what the England Peat Map are doing and what the AI for Peat project are doing, so we might not actually need to do it because that's what they're working on. But yeah, using remote sensing to identify areas of bare peat, which we know can be done really accurately, sort of 80–90%, so we could be really confident in that. Less confident in other types of vegetation, I think, for blanket bog. That's much harder to do. But also mapping those surface features would then allow us to, for all of our peatlands, have at least a remote sense perspective of what area of peat we've got in each condition category. So yeah, that definitely is the way that we're thinking, but a lot of that work could potentially be delivered by other people as well.
Sorry, yeah, I was just saying, there's also a lot of potential that, if the data you're collecting on the ground, it's not necessarily by specialists, that, that if it's collected in such a way that it then, can be fed into the remote sensing work. So I guess it's that, for me, it's a bit of a question of, like, is there scope to work with sort of people who do remote sensing work to then sort of make sure that, that it's transferable between the two, so you can use that ground-based data collection to then validate the remote sensing work.
Yeah.
Is that something that's sort of been happening or to come?
Hi, Nathan Torres from the Lancashire Peat Partnership. I was wondering if, did you mention that all this data will go to a sort of central hub, like there's the Peatland data hub that was been introduced by Leeds University? Is there a way that through this standardisation or hopeful standardisation of the data, it will all be put into this same hub that will be open access to a lot of people that can use this data for multiple purposes, such as research, and can be extrapolated to confirm the effectiveness of remote sensing, or to find possible new avenues for restoration techniques? Is that something that the National Trustee is considering to do?
So all of the data that we collect through the Eyes on the Bog monitoring will be entered into the Peat Data Hub. I don't think it's the Trust's role to create a database that data can go into for people to access, but if someone else was to create that database, then we'd be more than happy to add our data to that so it could be used for those purposes.
Okay, thank you.
Okay, we can have the last question, please, before we move on to the next presentation. Emma?
Sorry, I was just going to add to that in reference to Eyes on the Bog and certainly the Peat Data Hub. We're working closely with Water at Leeds because we recognise the wider need for the community to be able to access open source data and to collect data from other sources other than Eyes on the Bog. And I guess that's part of the Peatland programme's role, to try and identify those opportunities for collaboration and to try and support building that network. So we are working closely with Water at Leeds to try and expand and sort of bolt-ons to the Peat Data Hub. So I guess Eyes on the Bog in itself, Peat Data Hub already existed before Eyes on the Bog did, and we developed the bolt-on to be able to accommodate the Eyes on the Bog data. So we are open to kind of being able to commission and support further expansion of Peat Data Hub if you've got other elements that you think need to be supported. So obviously remote sensing data is huge in terms of storage size. We're probably quite a significant cost, but if that was something the community sort of identified as a need, we'd be happy to explore the opportunities for developing that.
Thank you very much, Leah.
Good morning. And firstly, thank you to everybody who's just managed to get all our tech working, because for a minute there, it's going to be very worrying, because we're going to make you work today. We're just going to tell you about the AI for Peatland partnership, but we have got an insight into AI, or artificial intelligence, and we want you to be part of that process. So, the AI for Peat partnership, what is it? Well, it's actually come about through a civil service data challenge. So there's a range of us from a bunch of different government departments. I'm from the Food Standards Agency. I don't have a background in peatlands. I have a background in geospatial. We came together as a set of people across government to say, what can we do to tackle the problem, and how can we pull resource, pull knowledge, pull skills, pull everything that we have to tackle that problem. So we, as a competition, we won that back in 2021, and since then we've been working to figure out how we can actually map all of the peatland and all of the peatland drainage features and those that have been blocked or unblocked on the peatlands. This is, of course, not on our own. We're doing this in connection with Natural England and for the England Peat Map team. Of course, once we've done that, we're aiming to share all of our knowledge, all of our data, and we're looking at ways to do that as we go forward. So, as we were saying, what is it we're really looking to map? Well, it's really getting down to these guys. So I'm sure that people in the audience are going to understand it a lot better than I, but it's from having had a trip out into the field, it's the dams, it's those drainage channels, those that are artificial as opposed to those that are natural features or natural drainage. And how are we going to do that? Well, I'm going to pass over to Sam, who's going to give you an insight into that.
Yeah, so as I'm sure many of you know, the ground peatlands, you see them from the ground. A lot of these features look like this. Can be easy to see at times when the vegetation lets you know, but a lot of the time, at least the sites that we've been, they're very hard to see, really hard to track manually, take a lot of time, whatever. Very good point. Yes, they look like that. They can be easy to see at times, hard to see at others, but very unclear at times. So what we do is we see them from the air. So we use aerial photography, where they're much, much clearer. This is taken from planes. We use resolution at about 12.5 centimetres, so we can see quite a lot of detail in there. And it allows you to see the kind of long, straight linear features that are the grips, as well as the kind of bigger, more natural channels, but ones that have been artificially eroded due to the grips, called the gullies. So this is a kind of standard area that we might be looking at. You can see we've got gullies on the north of the image with those grips leading down. They're quite obvious to see, but you know, maybe not towards the end. You don't know where they might lead. And for our model, this is what the output is. So we can see where the green lines are, that's where the gullies are predicted. Where the red lines are, that's where we see the grips. And this model is getting around about 70% accuracy. It's slightly misleading because it's thinking about how the overlap is between the ground truth and what the model's outputs are. That as an output is pretty good in terms of being able to say quite clearly where these features lie. Taking away the kind of base map, this is our sort of end output of the model where we can see quite clearly, you know, black background, nothing going on. Here are the green features, red features for our gullies and grips. There's still a few areas of inaccuracies, you know, where the lines are broken up, where it thinks it's a gully when it's actually a grip. But this is the kind of nuts and bolts of what we're trying to produce. It's just scaled up to the whole of England because this kind of map doesn't currently exist. And I'll now pass back over to Phil to talk about some imagery.
Okay, so because we're really looking at England, we're actually trying to go further than that with the methods that we've been working on. We need quite a large data set. So being part of government, we have access to what's known as aerial photography for Great Britain, which was established through the Geospatial Commission. It's a 10-year contract that will give us access to the whole of the UK. It's flown around 12.5 centimetres from spatial resolution, and it takes 3 to 5 years to get a full picture of the whole of the country. We did consider, and we still are considering, the benefits and the disadvantages of aerial photography versus satellite. Of course, with satellite platforms, it's a much better temporal resolution. We could consider the Sentinel or the Landsat series, because though we've got more sort of 40 or 50 years worth of data in some of those data sets. The downside of them is that the spatial resolution isn't as good as what you'll get from aerial photography, and that has an impact on the modelling that we're doing and how we identify features and what we can and can't identify. Having said that, we are also considering looking at commercial satellite providers, again through working with our partners in other government departments and the Geospatial Commission to try and get access to high resolution satellite imagery in the future. That may give us a sort of a happy medium where we can sort of start to look at really, you know, huge areas, not just limited to the UK. And to give you an idea of what it is with the different resolutions, this is spatial resolution. If we just sort of consider the images at the top of the slide, you can see on the left-hand side that the images are very pixelated. It's very difficult. You can see the features, but it's not as easy as what you would get on a much better aerial photography that's been flown at a lower altitude. And the other advantage, of course, in the UK is it's better for dealing with the cloud cover issues that you will get associated with satellite imagery. So what does this actually mean in terms of our modelling? Well, of course, with all remote sensing, there's still going to be an element of ground truth. It only leads you to the picture. It doesn't necessarily give you the answer. So we're still very much reliant on area teams and people in the field, practitioners, to go out and validate our data and verify what we've had. From some of the experiments we've done using some of our techniques, you can see that as the spatial imagery, as the spatial resolution, starts to become more coarse, it has an impact on the model. But you can see, though, that we still get some results, which is why it's worth considering the different resolutions. So, we've given you a bit of an insight as to how we come about. We've given you a bit of an overview to what we're kind of looking at and how our data source is. But to give you an actual go at what we actually do, I'm going to pass it over to Nick, and he's going to teach you now to become a You Only Look Once peat dam detector.
No pressure then. So I'm Nick, working at England's Earth Observation team. So again, I don't really have a Peatland background, but I've learned quite a lot about it over the last few years. I really want to try and, we go to lots of places and we talk to people that don't necessarily know about peatland, and it's really fun, like spreading the awareness of why peatland restoration is so important. Whereas you guys are peatland experts, so it seems like it'd be quite cool to try and talk about, demystify the deep learning kind of technology that we're looking at, and try and go through the process, like how does a deep learning model work. I wonder if you put your hands up if you have used an app, I don't know, that uses some kind of object detection to identify, so like a few people. I wonder if that's pretty good. So kind of this technology is out there, we're going to try and work out how it works. So we go through a process of collecting training samples, so we're kind of showing the model visually what it is we're looking at. And we use those samples to train the model. And then we try and make predictions with the model, and then we look to see how accurate those predictions are. And hopefully the predictions are quite good, and then we can use those to map the peat dams. So as you're all experts and have seen these kinds of things before, I wonder if you could I'm going to try and estimate how many peat dams are in this picture. We're trying to map the peat dams with no model training at all. So maybe you could put your hands up if you think there's like less than 10 peat dams in this image. Maybe, I don't know, 30? One hand, less than 50? 100 peat dams. It's quite hard. Because we haven't really shown you what they look like properly. And this is why it's important to train our models. So this one's got less peat dams, and again, like we haven't shown you what they look like. But you reckon there's like less than 10 in that one? Maybe? I don't know. So this is the first image. So what an object detection model does is it tries to put boxes around the features. So you could imagine if you had like a cat or a dog, it would be putting a box around the cat or the dog. But it's not just using colour. Like if you come across other machine learning algorithms like random forest, they're more focused on like the colour of the things in the polygons that they're mapping, or the boxes that they're mapping. Whereas deep learning is a bit smarter than that. It uses the edges, the contrast around the edges, and like the distinctive features of the dams. So we've got the boxes around the dams. You might just see some of the new glasses on. You might get to see some of the little pools behind it. When we were out in the field, we also noticed that lots of them have little overflow channels between them. And those overflow channels are quite indicative. They show up really well in the area photography. So there's some more peat dams in this image. They're mostly on one side. If you think on the left-hand side, you put your hands up. Ooh. And if you think on the right-hand side, I just realised it's flipped over for you. All the peat dams are over there. There's quite a few of them. Oh, it's not going to tell us how many. We'll come back to that. Unlike, I don't know, mapping cats and dogs, it's a bit more difficult because we haven't got the distinctive background. Again, there's some more. So this is like getting harder. There's quite a few here. Do you reckon over 50? Hands up for over 50? Oh yeah, we're getting good. I think we're getting good. So just to show you some pictures of what these actually look like. These pictures are from the West Pennines. You can see how subtle they look. So if you're out there in the field looking for them, just trying to map them manually, it's quite a challenging task. Some of you may have done that already. And the grips as well, kind of going across that image. And really we can see looking down quite a narrow channel of grips. And we've got like an eroded gully there. So in that first image, one of the earlier images, I think we had 8 peat dams. You can see that these are quite distinctive channels. So looking at our models, see our bodies, shapes. And I think the boxes were a bit faint, but they're kind of coloured by how confident the model is. So if they're green, it's really confident, and if they're more yellow, it's slightly less confident, and if they're red, it's not quite sure. There's no red ones there, so that's nice. So this is the one where they're all over on the far side, and you can see we've got 27 of them. And you can kind of start to appreciate that we're getting more and more dams in the image, and it might get more and more difficult to start mapping them. And as we zoom out, we get even more. We've got 179 in that small area. So hopefully now, you're probably getting quite good at spotting them from an image. And then we really start zooming out, because we're trying to map over quite large areas. This is like our textbook grip site from the West Pennines. I wonder if anyone, I don't know, hazard a guess at how many grips there are. Grips? Peat dams. Do you reckon there's hands up for over 100? There's quite a lot. Over 1,000? Oh, I don't know, 500? So, I mean, you can imagine trying to draw these manually. So we've got 1,106 that our models found in this area. And it's mostly quite confident because they're all mostly coloured in green. And it's interesting, they look quite, you can kind of see the pattern of them, the dark swatches. And you can see over here that's what they look like on the ground. So they're quite hard to spot on the ground, but they look quite good from above, we think. And I think that's why our model was able to capture them. Yeah, so hopefully that kind of gives a bit of an insight into how the models work. They're very much like training a person. So, am I the only sound in this bit? Oh, it's still me, okay. We practice. So we trialled, when we were doing this, we trialled quite a lot of different model types. There's lots of different architectures that work in different ways. A deep learning model has lots of layers, which is why it's called a deep learning model, and it's kind of the layers, the way the layers are connected and how it recognises stuff in the imagery affects how it will work. We've very much been trial and error, working out which ones work best. So we've got different kinds of different model types over there. And it's been a case of looking through and sense checking which ones work well. And we found the green model seems to work the best. The other ones seem to overclassify quite a lot. So that's probably the model type we're going to take forward. It wasn't YOLO actually, I think it was single shot detector, so but YOLO sounds cooler. So this is kind of the use case of it. You can see how it's really useful for people doing peatland restoration to target their efforts, to kind of see where they need to do work, so we can colour in where the grips have been blocked in green, and the ones that still need restoring in red. So one of the interesting things that came out of that when we showed this to the area team is not only could they see areas that have been blocked, they could also see within those areas, like the bits that contractors had missed. So they could pick out the channels that they hadn't done because maybe they didn't have time or they just hadn't found it. So I think that's really, really good. I think I'm handing over to Sam.
Yeah, so the last part of our presentation, I'm just going to give you a brief overview of the aspects of this project that sort of set it apart and make it a little bit more unique. Nick's touched on it quite a lot already, but one of the first things is the AI aspect of the AI of Peat. So with us, that means deep learning, so that's a small subset of AI. But it means these kind of neural networks. Has anyone come across the term or used them before? Show of hands. More than I thought. But essentially what they're doing is they are, as opposed to traditional programming, where you might be setting up specific rules on how to arrive at conclusions, you know, use a colour above this value, an edge here, input features more manually. This is going to take, say, something like an image, which is just maybe 1 million pixel values, each with a red, green, blue. And it's just going to do lots of different operations on them, feed them through, and hopefully arrive at some kind of answer. So for here, you might input an image of a face, and then on the kind of earlier layers, it might be getting things like, is there an edge here? Is there a corner there? Is there a bright patch? And then as you go further in, it might go to a collection of edges. Maybe it looks like a nose, maybe it looks like an eye, and then hopefully at the end, you can output something a bit more intelligent, like whose face is that? For us, obviously, it will be detecting grips and gullies, so you're trying to build up sequences of edges, maybe those strange overflow channels that Nick was mentioning, and the model will go, you know what, that's my final output, I reckon there's a bounding box here, I reckon there's a grip here, I reckon there's a gully, etc. So we have a few different types that we use in our project. Nick's already gone over the object detection, so that's localization and classification, where you're trying to find out where something is in an image and then what that thing is. For us, there's only one class, it's just a dam. In the future, we might want to split that up into types of dams, like peat dams versus timber dams or stone dams. And then most of the work that I do is on the instant segmentation, also called semantic segmentation, and that's kind of colouring in. It's almost like a more specific version of object detection. You're kind of colouring in the pixels dependent on what you think they are, so that gives you a bit more finer detail, and you can track things like what area of this land is gully or grip. You can try and convert that into a linear feature to understand what length of grip there exists in a certain area. So that's the AI aspect of our project that we employ to improve our accuracy. This is some of the kind of classic examples that you might see where AI is used to detect trees, detect houses. These are some examples within Arc Pro. I mean, AI comes up everywhere else. You know, everyone's got their kind of BirdNet, Merlin apps. You know, they'll use these kind of deep neural networks to input in sounds and output a species of bird. So they kind of crop up all over the place. Another aspect of the project which kind of sets us apart is the moving away from kind of more manual mapping. So instead of going down the ground or using imagery but manually going through it, which can take days, we instead use this quite high quality data. So Nick very kindly dedicated several weeks to kind of going over these gullies, creating these really quite detailed 2D polygons that we can feed into our model, and that just improves the accuracy even more, allows us to do things in the future, like understanding the profile of gully, what's the kind of drainage capacity, is it going to require a peat dam to fill it in, or is it going to be too deep for that and maybe it will require a timber dam, so we can kind of use that. And then the final aspect that makes this model, this kind of project different is the computing power. So a lot of more common projects you might do on a laptop. This is a PowerPC that Nick has, which is a lot beefier. It can be 4, 5, 6 times more high-end than your average laptop. Quite expensive. And then we are kind of transitioning away from that and towards cloud computing, which is even more so computationally beneficial. It has a lot of storage capacity. It gives you access to multiple computers that you can distribute your workload across. And for that, we've paired up with Microsoft and Databricks to give us their platform for using this. So we've been getting to grips with that over the last year or so. And yeah, it gives you, it means that you're not limited by that. There's just more compute than we know what to do with. So we can kind of process these large areas, we can generate that map of England's peat. And then finally our next step. So, you know, we're kind of using that cloud computing to scale up to the whole of England, and hopefully we'll output a map of that by March 2024. So it's only a few months away, which is a little bit scary. And beyond that, we'd like to kind of scale up to the rest of the UK, Scotland, maybe beyond. I've mentioned, you know, with the added detail of the data, you can understand the profile of grips. We also want to maybe understand the carbon capture potential of filling in those grips. Nick showed a slide earlier where these features, all these grips and gullies and dams were put together into a dashboard. That's one of our goals, is to have a kind of interactive use case for restoration teams and anyone who needs it, to more accurately tell what they've got on their land, what areas have already seen restoration, what needs restoration. And then continuing to build these kinds of partnerships with people like Databricks, with DEFRA, with Microsoft, just to kind of pool all our resources together and build the best kind of model that we can. And that's our presentation. Thank you for listening.
So, as you know, my name's Dr. Ismaila, and I want to introduce Dr. Alex Hamer. We both work on the England Peat Map project. If you're wondering who we are, here's the Rogues Gallery. So you can see there's actually quite a lot of us doing it, and quite a range of different things. So what are we doing? We're trying to map the extent, depth, and condition of, well, it says peat, it's actually peaty soils in England, which is a big, big task. So it's kind of the AI for peat project on steroids. We're kind of expanding out and trying to map and understand everything. And as we saw on day one, we're all, you know, the need is huge. There's a huge, there's a 2 million hectare restoration target in the UK peat strategy, all these projects scaling up, and we actually need, but we still don't know where the peat is, how deep it is, and what kind of condition it is. We don't know that, and that's critical for greenhouse gas reporting. It's critical for development of policy and funding and revenue streams to go into restoration. So, what we're going to be producing, we're going to be producing a peat extent map, a peat depth map. We're also going to be producing some vegetation and bare peat maps, and there's also surface features, but I won't talk more about those because you've already seen quite a lot of what the AF for Peat project's doing. So, to do that, we are taking a computer modelling approach because the cost of sending somebody to all of our peatlands and doing that assessment would, as you can understand, huge. So we need to take a modelling approach, and we need to get the computer to try and predict where the peat is, where the depth is, where the different vegetation classes are. So we need lots of training data. So we've already gathered together lots of historical and external. We've already got 3,500 observations, and you can see all the little dots on the map. A lot of that's come from people in the audience, so thank you very much. If you've still got any more data, please do send it through to us. It's really valuable. We've also got a field survey, which I'm responsible for coordinating. So we're going to be getting over, it's nearly 7,500 quadrats, and a hell of a lot of peat depth measurements. We're also using BDS border data, agricultural land classification, to actually tell the model where the peat isn't, because that's actually really important, because the computer doesn't know the difference. Otherwise it would think there's peat everywhere. It wouldn't be great if peat was everywhere, but hey-ho. We have divided the country up into different areas called biogeographical zones to try and see if there's differences. That's what we've seen in the Fens. The Fens are very different to Northumberland or the Pennines or Exmoor and Dartmoor. So we've divided that. We stratified as well, so we divided up, we've got, the shallow peaty soils, small peatlands, lowland peatlands, transition areas. Those are kind of our target areas. That's where we need a lot more data, and we've got a lot less understanding about them. Whereas, blanket bog peat is actually a lot better known because there's a lot more data there as well. We're also looking at wooded peaty soils and valley mires as well. So we all actually went on trips to New Forest, which was really interesting. But there's a kind of real-world element to this, which is access permissions, surveyability, time, money, data licensing, which we'll talk about later. Just a quick thank you to everybody who's on this slide. You've all given us some of your data. I'm sure you've got some more on a dusty shelf, so please do dig it out and get it to us. But it's really brilliant. Right, soil survey. I'm not going to go into the details of it too much. We have clusters and transects. The transects are looking for where we get a transition, from deep to shallow, shallow to nothing. So that's what we're trying to pick up and train the model. The clusters are more about getting the kind of peat depth data and focusing on an area and trying to understand what the variability is. So that they're 1 kilometre kind of square area. The transects are 1 kilometre long. It's basically what a surveyor can do in a day. It's, once again, coming back to the practicalities. I'm also doing a lot of QA work, and you can see, all the kit that we've used and the soil pools. We've decided not to use depth as a definition for peat. We are only using organic content, and that's deliberate, and that's to make our models and our maps usable and future-proof. If we put a depth criteria, we will just exclude a lot of organic rich soils in England. So we're going to leave that argument for other people to make. They can use our data and apply whatever criteria. So if we change and say, oh, peat's actually 20 centimetres deep, then you can see that in our data. If we want to change it to a metre, you can change it. So there's actually one of the surveyors in the room. Hi, Ella. This is a contractor. This is us actually on Engine Farm, so the Great Fen project. So I did some training with them in January there. So that's a photo from the UAE, and you can see, some of the soils data that we're getting. So you can see some of the peaty material right up at the top, but then you can see the mineral soil going down. We typically go down to 40 centimetres. But where there's buried peat suspected, like in this part of the world, we do go down to 1 metre. So at the moment, we've done about 100 clusters and 20 transects, which is about 20% of our requirement. We are running behind, sorry guys, but you can imagine with the scale of what we're doing, it's really quite challenging. We're also doing vegetation survey. Alex is going to talk a bit more about the details, so I'm just going to briefly kind of gloss over it and probably butcher it and watch him wince, which is going to be quite fun. But we're going to be gathering 2,600 quadrats. Because Alex is a pain in the ass, because Alex is using satellite data, there is spacing issues for, the resolution of the satellite data is 10 metres by 10 metres, so we're actually having to do some pretty great big whopping quadrats out there, and also they can't be too close to each other. So you can see here, we've got, that's the main quadrat. Within this square, you can't have any more quadrats before you put the next one on. So it's been really interesting as kind of, I come from an ecology background, and it's really interesting actually working with, with the Earth observation and the kind of adaptation of what we're having to use. Also getting surveyors to kind of rewire their brains completely from vegetation. Vegetation, we deal with multiple layers, and so often a quadrat will have 150% cover because we've included all those layers. For this, no, I've had to tell them, no, you've just got to tell me what the satellite can see. So it has to add up to 100%. If you've got more than 100%, then you've gone wrong. And that's kind of really having to rewire an ecologist's brain to work with the Earth obs data. This site's next to Woodwalton Fen. And it just gives you an idea, this is what one of our 10-metre quadrats actually looks like on the ground, and the little flags are where we're taking peak depth points. So for the vegetation, where we're up to, we've done 1,912 out of 2,600. We've got lots of different vegetation classes. If you were here on the first day, you're seeing Chris Evans with his different categories. All ours are based around those categories, so they're directly linked to greenhouse gas emission factors. So all our data and the modelling can then be used to input into the UK greenhouse gas inventory. So we can see we've got sphagnum-dominated area from Melenia-dominated Kaluna, drygrass and scrub bog, short fen, tall fen and scrub tree fen. And you can see sphagnum, we've only got 11 quadrats, and we're actually having to change our criteria. No one's really done this before, so we were being optimistic in the area of sphagnum that we would find, where you've got to have a 10 by 10, where sphagnum covers 60% of the quadrat and is visible to the satellite. But I thought we'd give it a go. We're shrinking that down to 15%, but with a 60% understory to address that. But as you can see, we've got healthy numbers for the other ones. For the tree ones, they're slightly behind because we had to wait for the trees to be in leaf, because we did start in January. It was really nice to see that Tia has been doing some app work. We have as well. We're using Esri's Field Maps platform to help facilitate the data collection. We also have dashboards to help manage all the analysis and see progress, and we also use it to help manage the landowner permissions. So it's been invaluable for a big national survey, you know, and all the data goes straight into the database. I can literally see it. Once the surveyors sync their data, I can see it immediately. So I've actually had them on the phone saying, I've had problems syncing, can you see my data? And I've logged on and gone, yeah, I can, and I can see it straight down the phone. And we can see the photographs of the plots, we can see the data they've collected, or also we've been able to automated QA analysis on the data coming in, so we're able to highlight where people have made mistakes and give them feedback as well to say, hey, you know, are you sure you put that number in? Are you sure that's right? So that's been really, really kind of invaluable. Now, as I mentioned, it's about the vegetation categories that Chris Evans has produced, but this is the point where I hand over to Alex.
Thank you very much, Chris. So Chris has spoken a lot about sort of our data collection. So obviously, just like AI for Peat, our project is extremely data hungry. So today, instead of obviously all these different maps we're collecting, so obviously we're going to be producing the extent of peat, depth of peat in centimetres, condition maps as well. So one of those is the surface features, and then one of them is the vegetation, which is the main bit that I'm a part of in the project. So basically, we've picked vegetation as this, we can use vegetation as a proxy for the condition of the peatland site. So yeah, we used UKCH's sort of condition categories to base our vegetation classification around. And what we really wanted to do was really just focus on the evidence gap. So we didn't want to reinvent the wheel, because there's already a lot of maps that were already mapping a lot of these condition categories. So for example, woodland, forest research do a lot there, obviously with the National Forest Inventory. Then also there are trees outside of woodlands as well as grasslands, croplands and extraction sites as well. So we predominantly focused on the semi-natural bog and semi-natural fen categories, which Chris mentioned earlier. So I'm not going to go through the ins and outs of machine and deep learning modelling, so I'll just sort of be very high level, but if anyone wants to discuss it more in detail afterwards, let me know. But we're using these types of modelling approaches, as it's impossible for surveyors to survey every single area within England's peatlands. So I've drawn two boxes around the condition categories. So these are basically the resolutions that these output maps will be at. So we've got the normal vegetation map, which will be a 10-metre resolution. So as Chris mentioned, that's because we're using satellite imagery, and that's the highest resolution we're able to use from free satellite data. But we're also doing some bare peat modelling as well, so that's very similar to the AI for Peat's approach by using a deep learning model. And because we're using aerial photography for this, we're able to get a more accurate, a higher resolution map, so 25 centimetres resolution. which will be primarily in the upland areas within our Peat extent. So some of the other data that's going in is Sentinel-1 data. So this is a radar satellite from the European Space Agency. And then also we're using Sentinel-2, which is an optical-based satellite. So that's RGB, near infrared, and other parts of the electromagnetic spectrum. And then we're also using the aerial photography of Great Britain as our source of the aerial photography. In addition to the Environment Agency's LiDAR data set, so this is essentially a type of elevation data set. So I think a lot of people saw it yesterday, sort of identify rodons and things like that, obviously on the fens, but we use it in a slightly different way to sort of help us identify the difference between short vegetation dominated and tall vegetation dominated. As I mentioned, it's an extremely data-hungry project, so we've used a lot of existing data sets, which has been fantastic that the community have actually engaged with us and provided us with data and also data licenses for this, so that we're able to use it for our project. And then also supplementing in the field survey data that Chris discussed earlier. Something that Chris forgot to mention is that all this data will be available afterwards under an open government license as well, so everyone has access to all of our peak depth data, our peak presence data, and also all of this vegetation data as well. So I thought I'd just give you sort of a flavour of sort of what's currently ongoing within the vegetation mapping product and what it's actually going to look like. So we've recently done our alpha release that's for internal use only. So we're getting around an 89% overall accuracy across all of our classes. So I've sort of provided a subset here of one of our BGZs, one of our biogeographic zones, which is over Yorkshire. And then sort of zoomed in over, but it's not too far from Thorn and Hatfield. So yeah, so you can sort of get a flavour for what it is that what the map's actually going to look like. So it's quite interesting, obviously you can sort of see sort of areas of cell bunding, obviously that woodland encroachment as well. So, like I said, some of these layers we haven't mapped using our own techniques. We've taken them from other open government layers, like the NFI, for example, obviously for woodland. But we're also using arable areas as well. So that comes from the Crop Map of England, which the Royal Payment Agency have developed. But yeah, but it's, at the moment it's looking very, very good for our alpha release. Sort of nationally, obviously I've just zoomed in onto Yorkshire. We're sort of getting an 82% overall accuracy for our product, and I can sort of go into the details either in question time or afterwards on sort of some of the areas that are working better than others. One of the main things that we're quite aware of is obviously I've just whacked out this accuracy figure, but obviously, you know, for the whole of England I'm saying 82% accurate, what the hell does that mean? So we sort of thought about this and thought, how can we actually get feedback on our maps? So we've been developing a data feedback portal. So this is a online platform that's hosted as an ArcGIS online layer, where we're actually asking you, the community, to feedback on our maps to help improve them. Because obviously you know your local patch better than a lot of the people in England Peat Map would, and a lot of other people. So really the aim is to engage with you to improve these so that they're the best product that it can be. So I might leave the demonstration, but I'll ask the chair at the end if there's enough time. But essentially you can log into this feedback app and sort of put a point in and say what it is that you want to discuss. So you can either say, yes, this has worked really well in this area, the peat depth's correct, or you can be like, actually this is vastly overestimated the amount of peat extent, or this is the wrong vegetation type. And then we can then use this as data to actually feed back into our models. But really, it's reiterating the point again. Obviously, our project's very data hungry. So if anyone has any data they think might be useful for our project or for AI for Peat as well, please let us know. So I've put our email address on there. So that's peat presence, so that's just if there's peat there or not. Depth, so depth in centimetres, that would really be useful for us. Vegetation as well, so any vegetation quadrats you've done, it doesn't have to be the 10 by 10 metre quadrats that we're using. Obviously we understand that a lot of external surveys don't have that requirement, a lot of them are 2 by 2s, but we can still use that data, in addition to the other surface features as well. Tia kindly mentioned our data standard earlier. So one of the things that I've noticed last year at the IUCN conference, everyone was chatting about data standards quite heavily. So this is one of the reasons why we've decided as a team to actually try and tackle this. It was brought up. And really it's about the consistency across the data collection, so that we actually understand what the strengths and the limitations are of the methods that we're all using. So yes, the England Peat Map project decided to develop it for a peat depth survey that was developed by us but kindly hosted by the IUCN, so it's on the IUCN website for people to have a look at. And yeah, and I guess one of the things that we're quite interested in as a project is, have people actually seen this standard? Have they used it? I don't know, is there a show of hands, anyone that's seen the standard? Right, that's good, yeah, I'm glad people have seen it. Has anyone actually used it yet? No, yeah, so I think this is one of the things, I think that for standards, it's all well and good people, you know, making them, but unless people adopt them, obviously, yeah, they're sort of redundant. So this is really one of these things that I think is quite an iterative process. And yeah, there is obviously more work that needs to be done for standards. So Tia mentioned, obviously, standardising, for example, you know, the way that the things that we collect for vegetation quadrats, or the way that we collect data for surface feature mapping. So that's the end of the England Peat Map presentation. If we invite someone from AI for Peat for questions as well, and then we'll take questions jointly. Tia, yeah.
So while people are just coming up and sitting on the stage, I just want to set the scene a bit. We all know the urgency. We all know the scale of the challenge. We all know the huge amount of work that's already been done. We're all sat on these mountains of data that we've collected, but it's not in a form that can be shared. And therefore, we can't answer key questions about, you know, we can't say where the peat is and where the peat isn't. We can't say what condition it's in. And going forwards, we need to know that. We need to go beyond restoration, which is the theme of the conference, and go, well, how are we going to track the condition of our peat bogs? How are we going to show that we're keeping them in good condition? How are we going to know when we might need to go back to them because of the challenges of climate change and the biodiversity crisis? So, where do we want to go with this as a community? Emma, you know, said, you know, in the question she asked, you know, the IUCN's here, you know, but they're guided by you guys, the community. What do we want? Where do we want to go with this data? What should we prioritise? How do we maximise the opportunities for sharing that data and analysis? What are the key barriers to it? We've already mentioned something. Tia mentioned about there being a need for a lead partner there, and also we've seen from the AI for Peat team and a bit of what the Peat Map was. We've got all this new amazing technology. EarthObs, 10 years ago was nothing on this scale, and we're seeing huge, rapid advancements. How do we take advantage of that to help address the huge need that we have? So hopefully that's teed it up for you. We'll open it up for questions for the speakers and any comments and thoughts.
Hi, so I'm Carol Hopwood-Lewis. I'm the Senior Historic Environment Advisor for Peatlands at Natural England. I think I've spoken to some of you guys before. Something that concerns me a little bit in this presentation, and I think Maura picked up on it earlier, was the siloing between the natural and the historic environment, and we need to know about both of these things in order to restore our peatlands. I wanted to ask about join up with the RKI similar surface feature research that's been done by Forest England, particularly the deep machine learning on looking at forest plough on peat, because I feel like there's an obvious join up with your data sets in terms of looking, you've only currently got a 70% accuracy rate, but you're looking at a national rollout, which seems low to me. And on your diagram of feedback, what you didn't have was a segmentation of your errors and then looking for training data sets to categorise those errors. You're still putting in your original peat down data sets into the training algorithm. So there's an opportunity there to join up But if we don't look across the different sectors and find that data from other people, and the same issue goes on with the Peat standard. I have seen it, I have shared it with my archaeological colleagues, and they pointed out that because it doesn't have a few basic things that they're interested in, they won't use it, and therefore they won't record their Peat data in a way that we can then feed back into the natural environment sector. So it's more of a point than a question about we actually need to stop doing this. We need to join up better and create data that is interoperable so that it works for all of our purposes, and then you can have, we've got tons of data that, I mean, Chris even asked for it at the Flag Fen trip yesterday, can we have your archaeological data? It's like, we would love to give it you, but the format that you've asked for it in doesn't work for our purposes, so if we can have those conversations, that would be really useful.
If I can just start, and then I'll pass on to some of the more technical bit, but just a bit of a reflection in we need to start small and grow and build it up. Over a decade ago, I was stood at the IUC conference. We've been having the same conversation about data for over a decade, and nothing has happened. And it's because of the scale of the problem. So I agree entirely with you. Yes, we should aim for that. That should be, fully joined up with, the archaeology and all the other data. I agree with you entirely. But at the moment, we have no data sharing. And so we are starting small. We're starting with our immediate need and then building on it. So for the Peat map, we started with just peat depth data. We're collecting a lot more than peat depth data, but we were starting small and then building up. We would greatly welcome the feedback from, the other archaeological people that you've been, and we can adapt our standard. That's the whole point of it. It needs to be suitable for the whole community. We have put it out and asked people for that. So, it's all about us kind of working together, because there's so much restoration data out there. There's so much archaeological data. And it's really bloody hard to get hold of. And, the amount of time that we spend doing it. Right, I'm going to shut up and I'm going to hand over. Who wants to take, the kind of accuracy question and the other bits?
Actually, really interested to join up on archaeological stuff. Is that what you said? Mm-hmm. Historic environment stuff. I can join up on that. That would be really good. On the accuracy, we said 70%, which is our overall accuracy for grits and gullies. I think we've got a bit higher for peat dams, but we're partway through the project. We've got a limited amount of training data. We're currently working through how we can improve the accuracy. Training data seems to be one of the limiting factor. So a lot of the data that we've got has come from grit lines. So they're just a little line going on the grit. And then to train the model, we've kind of applied a buffer, which seems like a good fit because it's quite time consuming to digitise these features. So that seems to work quite well for the grits. And for the gullies, they're kind of much more chaotic in their shape. So they're natural features, so we've been kind of working on digitising those features. And that does seem to improve the accuracy a lot. So, we're working on ways to get the accuracy high. We're going to bring in data from other areas. I think aiming for 80%. So, Living England, which is a national habitat map, are achieving 85%, I think, is their ballpark figure. There's all sorts of questions about how we measure accuracy. So,
Yeah, I appreciate it. It's just 70 seems a bit low. And I know it's a tricky topic, but I think possibly some of your problems are because you've decided that something's out of scope that is putting off your accuracy because you've decided it's out of scope, so you're deliberately not looking at it. So I just wanted to raise that possibility, and perhaps we can have a talk about it outside of this session.
Just to follow up on that, so just to say that, sorry, Anne Williams from the AF tailed on the back end of the presentation, but just to say we're sort of in our infancy with the AI for Peat, And I think we've been growing the team, gosh, for the last year. So I think we're in the stages of actually starting to build up, I guess, what we want to go forward with the object detection. We're looking at, you know, we can see this sort of technology with various use cases. So we're sort of doing this incrementally. So yeah, feeding that back then to get feedback in sort of hopefully the next 6 months. So yeah, we're sort of trying to build this team. We totally understand what you're saying in terms of, okay, how can we make this better and sort of extend this to a wider stakeholder group. So hoping to do that at some point.
Well, also, if we just look at the bigger picture, if you look at all the other data sets that are out there, they're not 100% accurate. There's a lot of areas in the data set we're never going to get to 100% accuracy. That's built of it. You know, we're using remote sensing. And let's also take a step back and look at what's the starting point. Our starting point is nothing. We don't know where, we've not got reliable data of where it is, where it isn't, its condition. So anywhere is upwards, really. So even if it's only 70% at the moment, 70% is better than nothing. And we're starting with nothing. So it's a significant stride forwards. Yes, it needs to go higher, and yes, we're all working hard to go in that direction. But, you know, as Anne said, it's rapidly evolving and it's rapidly working, and when we get more training data as well, those accuracies will go up.
I think that also as well, it'd be great, I think the IUCN is a really great opportunity to link in with so many different stakeholders. I think that generally you are right, we are quite siloed, and I think IUCN can really demonstrate that in terms of, oh gosh, this is really quite broad, interconnected, you know, trying to solve this problem, especially with developing this technology. I think these, you know, this is a great conversation to be having. It's a great opportunity to link in. So I think, yeah, you know, we have our contact details on the poster. Feel free to come and link in with us later on. I think it's just, yeah, it's following on from these conversations that will help shape this technology to be, you know, better adopted and better used.
Do we have any other questions?
Yeah, it was to add in about the siloing effect, and that it's become one of the problems I think with devolution, because like you guys are doing this for England. Colleagues of mine and I have done very similar for the flow country in Scotland, and Wales again has a different methodology, and there doesn't seem to be a great way of working together across the nation so much anymore, and also working across projects. I think that's something that, I mean, it's a bit of a comment really, but it's something that I think we need to change to work much better across projects, and it's with the way things are funded, it's very difficult to break out of that, and I want to know if you guys have any thoughts on how we can achieve that.
I mean, if I can just chip in from the England Peat Map perspective, we did actually reach out and have conversations with the people working in Scotland, Wales and Northern Ireland, you know, on the Peat Map, and we did do some information sharing and things like that. But I agree with you entirely. You know, it does make it challenging. You know, with devolution and the different approaches, and even the different definitions. Going way back when to the IUCN Commission of Inquiry process, Scotland's got a different definition of peat to England. So if you imagine trying to, you know, you're trying to compile data about where the peat is and, you know, where the habitat is, and you're using different definitions. So that makes it really, really hard to start off with. Does anyone else want to? Does anyone else want to chip in?
Just to chime pretty much exactly what you said. I mean, the AI for Peat is come from a cross-government collaboration, and we've had this investment to be able to, you know, create this technology with the idea of sharing and scaling eventually at some point. That's one of our objectives. We've really struggled with the cross-government collaboration.
I think one of the drawbacks that we have is just being able to attain the funding and the resources, the capability. We are seeing that improve, and we are looking to join up with, you know, the devolved government. So that is on our agenda. I think that it would be a shame to not extend this technology. It's happening at a slower pace than we'd hoped, but it is something that we are keeping in mind. It's just trying to get the buy-in at each stages, and sort of, you know, as we progress, we're showing that technology, and then it sort of generates enthusiasm. But it does take a lot longer than we hoped, and it is a bit of a challenge for us.
Anyone else?
Yeah, I think Anne hit nail on the head with the cross-government working. That's been really difficult, data licensing, or setting up agreements and all that stuff. Yeah, other projects as well, like Living England just covers England, but there's also a Living Wales, which maps general land cover in Wales. I don't know if there's an equivalent one for Scotland. You've got LIDAR, the Environment Agency just cover England, and then a whole different LIDAR project for Scotland. So it's all very disconnected, and I think it is quite hard to join up, just because it's deeper rooted than the level that we're sat at, I guess. Those are just my thoughts.
Thanks a lot for the question, Jenny. Yeah, I'd say it's really interesting. I think it's one of the things when I came to England Peat Map, I found it quite interesting that there isn't a standardised way to, for example, map, for example, my bit, obviously the vegetation across Peatland, and then obviously UKCEH is obviously UK greenhouse gas inventory. I think that sort of, for me, was one of those areas where I was like, we can standardise this. Obviously, it's across the whole of the UK. It's not just England specific. So I think for EPM, that's why we've decided to, do something like that, because obviously it's comparable with the work that you guys have done in Wales. And hopefully, I'm more than happy to collaborate more as well, obviously, with the EPM side of things for England, obviously, from what you learned in Wales. But I do agree, though, that there needs to be a lot more collaboration.
Thanks for that question. Tia, do you want to ask yours?
So my question's for the AI for Peat project, and it's specifically regarding that ground truthing. So that was carried out on that site that you were showing the maps of. So can that ground truth data be applied to different sites? And if you do that, will that likely reduce the accuracy that you get?
Yeah, that's a good question. So I think we've done lots of ground truthing in the West Pennines. The West Pennines kind of been our test site because we've had a lot of access to it. We've been collaborating with some people from the local area team. We've been out on site and seen lots of the features, so we've been using that quite a lot. If we could get that kind of accurate data from other sites, I think it would really help. One of the things that would help us is getting examples from areas of peat that look quite different to the West Pennines. So we're about to embark on looking at some ground data that we've got for forests of Bowland, because in the aerial imagery it looks a lot greener. So you have to forgive my ignorance, but I guess there's different vegetation going on around there. One of the hard parts is that the data that we get that we collect on the ground tends to be lines, linear lines, which is great, but the deep learning models need the outlines. The models pick up on the outlines of the shapes. So we need to be telling the deep learning model precisely where those outlines are, otherwise it just doesn't know. Like if we just draw a straight line through the wiggly edge of the grip, we're effectively telling it that the gullies have straight lines, but in reality they don't. So we don't really seem to have much data that really has that level of accuracy that allows the models to pick up on complex features. And there's lots of differences in colour as well, so it is quite challenging, but the more data we get, the better. So does that answer your question? A little bit.
Right, okay, we've got about 7 minutes left. I appreciate you might still have questions about the talks. If you could leave that till lunchtime or email or whatever way. And if I can just bring you back to these kind of key questions, because I'm very keen for us to be able to actually come up with even just to start the conversation with the IUCN about, you know, what do we want to do with this data? How do we move the sharing forwards? You know, what are the problems that we've got in sharing this data? So, does anyone have any thoughts on that?
Hi, I'm the Data and Evidence Manager at Yorkshire Peat Partnership, Beth Thomas. One of the barriers that we have, that I think you're probably quite familiar with, you touched on it in the talk but didn't expand on it, is the licensing agreements. So obviously we don't own any of the land that we survey, and the data we collect is under various different agreements. So if we collect it through Natural England funded countryside stewardship, it's under a Creative Commons license, and then an awful lot of our data is collected on various other projects. And so we have that issue with sharing our data is we have to get landowner permission in a lot of the cases, and even if we don't actually have to get landowner permission, if we want to share data from a few years ago, we'd like to get landowner permission. We'd like to go back to the landowners and say, yeah, we did this survey a few years ago, we have the right to do this, but we're letting you know that we're now going to do this. And of course that brings up a lot of issues because a lot of landowners are not necessarily keen on sharing their data, so I don't know if you've got any thoughts about how to do that. We can obviously look at different ways going forward of making sure that we explicitly say it in our agreements, but for a lot of old data, that becomes a very big job for us to go back to individual landowners and discuss those issues. And then obviously we've got, if we aren't on a separate issue of another barrier is just, if we all get on the same standard of way of collecting data, that obviously makes it easier to share. Because at the moment, of course, the data we have is not quite the same as the data that everyone else has, which must be a big issue that you find when you're collecting data for the different projects. So there's some of the barriers. I don't know if that's a particularly helpful way forward, but that's some of the issues we have in sharing the data that we have.
No, that's really useful to hear. Thanks, Beth. I think somebody else had their hand up. There's one up there and there's one up back there as well.
I suppose if we're, you know, the theme of the conference is beyond restoration, one of the key things it would be nice to see is how we are, you know, moving away from, you know, where the ditch blocks are to where the hydrological restoration is, so that we can then put all those figures into carbon calculators or biodiversity net gain or whatever it is that is coming our way. So that would be the next step that you know, I personally in our project would like to see coming our way. I know I'm one of those people on the naughty step that needs to share data with you. So yeah, just to say we have a lot, when we do restoration, we collect a point for every single feature that's put into the ground. So we have that data to enable you to do some of your validation, really. And we've been doing lots of vegetation sort of surveys and everything, so that information is there, and I will try to get it to you. But yeah, so just keep hampering me, or pestering me, should I say. But yeah, restoration, hydrological restoration, to know what it is we have achieved, really.
Thanks, Morag. Yeah, I mean, one question that I've got for the audience before we come to the gentleman back there is, what's the barrier to taking up the data standard? Very few people in the audience put their hands up when they said about the data standard that we've produced. And, you know, if we want to share the data, we need to at least be having, it's basically the same format that is collecting. You know, we can collect lots of different data, but there's key critical data that we need, like peat depth. You know, we need to know, have you reached the bottom? People don't record that, and so we've got data sets where there's lots of 1 metre, 1 metre, 1 metre. They only had a 1 metre stick with them, but that doesn't sit with the data. So, you know, what's the barrier to taking up this data standards? What's needed to push that forwards to then, you know, we've already heard we need somebody to host a kind of data hub where it can all come in, but how do we get the data in a form to get it in that data hub? And how do we overcome that barrier? Anyway.
I was just going to make a comment on kind of the historic data. So one of the biggest barriers is just how this sector is funded, because all of the funding is for current or future restoration. Pulling together historic data from, say, 20 years ago, that is a full-time job, and because of how these programs are built kind of quite organically, people move on, going and finding all that data in every program's individual system is very hard. And I think if government bodies are really serious about getting a grip on historic data, they need to start putting money into funding people to do that properly.
I kind of agree, and I think it's a policy question. You know, we've got the policy makers asking, you know, where is all the peat? What is the condition? What are the greenhouse gas? They're asking all these questions because it's important to them. But all the focus has been on dealing with the problem, restoring it, which is understandable. But I kind of agree with it. I think we do need a lot stronger ask for that kind of, for the monitoring data, the data standardisation, digging out of people's cupboards and blowing the dust off the data and making use of it, because it's going to be so powerful. Do we have any other? We're just running out of time. So last question. That's all right. I can keep going if people want to go into lunch break, by the way.
Sorry, Chris, it's me again, and I confess I haven't seen your data standards, so this might be a stupid question, I'm sorry. But
you can join Morag on the naughty step.
Thank you. Does your data standard include being able to put in the information for things like depth of peat rod used, or type of dip well used, or things like that?
Yes, it does. You can say what peat rods you've used, and there are some compulsory fields that are kind of essential, but there's also lots of optional ones in there as well that you don't have to use. So if you're doing a different methodology, but it's an evolving standard, and it will flex around people. There is core piece of data that we all need, but there's also a lot of variety out there, and we don't want to constrain that variety and that innovation. We want to just help facilitate it and make that data shareable. I'm just where this lady over here hasn't had this to say. Do you want to have the last word?
It's just a question, actually. Sorry, it's more about you talked about sort of area data, satellite data. But one I have those on annual, and it sounded. So how is that going to affect monitoring if your data is you can only verify your data every 4 to 5 years? And can I ask how often your data sets, your aerial satellite data is refreshed?
Okay, I shall hand that over to the experts and run away. I'm a field ecologist. Go on.
So yeah, it's a really good question. You're quite right. The aerial photography for Great Britain there, 12.5 centimetres that we're using AI for Peat, is about every 3 years, I think, sometimes, for varies a bit from site to site. And then the Sentinel data refreshes, I think it's every month, something like that. Depends on cloud cover and
Yes, so it's every 6 days. But for example, in the Peatland, yes, we're doing it once every couple of years. Hopefully, what we're hoping close to this.
But we're also, there's a project at the moment looking at high resolution satellite data from Airbus. That gets down to 30 centimetre resolution using Pleiades NEO, which is a constellation of satellites. I think that they have to be tasked. I think you have to request data if you want particularly large areas. That gets down to 30 centimetres, which may be good enough for us to do some of this grid mapping. It's something we're going to try and investigate. And then that would hopefully give us monthly or at least a few times a year, we'd get some new satellite data potentially.
Okay.
To build on what you've been asking, the other thing to consider is the longevity of some of these platforms. So some of the satellite providers, they become deprecated. There's thousands of satellites that go up every year. So in the context of the peatland restoration, where I'd imagine it takes a long time to see the results, for projects like these, we're going to have to think about how we're going to be able to get that amount of data in the future, and can we keep it running? That's another area, I think, for exploration.
Is there any way to say, because you're going to show it's going to be historical then, so if someone's got a project, they're going to go, well, I know it's all been installed, or I believe it's been installed. Is there any way you can link up, say, the DCS and the actual contractors who are doing the work, who've got live data saying, and then it's the satellite data to lay it, basically?
Yeah, absolutely. These are the things that, in terms of the actual projects that's moving forward, we're starting to get engagement with that. It's about looking at all the users in the whole process and what you need, and then we can identify that so we can take the whole thing forward.
And also just to add, some of my Natural England colleagues are actually working on getting kind of restoration data in and combining it all together, but there's also delays in that coming through as well. You know, so we're never going to get quite to live. And the other point is a lot of it's cost. You know, if we've got free access to the aerial photography lane, or we've got free access to the Sentinel, you know, we've got free access to the 10-metre resolution. There's a lot more detailed resolutions there. It's not that it's restricted 10 metres, it's just that you have to have a lot bigger pot of money available to do that. And that's then takes us back to going back to the policymakers and making clear, coherent arguments that we need to get the right resourcing to answer a lot of the questions that they're asking, but also to help answer a lot of the questions that we're asking. We need to wrap up now because it's lunchtime. Thank you very much for your participation. I hope it's been useful and hope these conversations continue. Thank you.